This is part 3 of section 4.3. Let's just talk about some example problems. Okay, from the information given, find the quadrant in which the terminal point determined by theta lies. So remember, we just talked about something like this, and we said all students take calculus. So this tells us which of our trig functions is positive in that particular quadrant. So let's look here. Our sine is greater than 0. So sine is positive. Where is that? Does that happen? Sine is positive in quadrant 1, and sine is positive in quadrant 2. Okay. And cosine needs to be negative. Where is cosine negative? Well, cosine's only positive here and here. So it is negative in quadrant 2 and quadrant 3. So what quadrant makes both of these true? Your answer here is quadrant 2. So sine is positive and cosine is negative in quadrant 2. Okay? Tangent is positive and sine is negative. Well, tangent is positive in 1 and 3. Sine is negative in 3 and 4. So where do both of these happen? In quadrant 3. Okay. Here, cosecant is positive. Now remember, these are reciprocal functions, cosecant and secant. And cosecant goes with sine, and secant goes with cosine. So basically we're being asked, when is sine greater than 0 and when is cosine less than 0? Well, look right up here. Sine greater than 0, sine greater than 0. Cosine less than 0, cosine less than 0. These two problems are the same. They're just written in terms of the reciprocal function. So where does this happen? It happens in quadrant 2. Okay. Now, where is cosine less than 0 and cotangent less than 0? Well, cosine is negative in quadrants 2 and 3. Cotangent, which we're going to look for tangent, being negative, happens in 2 and 4. So where do these both happen? In quadrant 2. Okay. Now we're going to use the same ideas to find the sign of the expression if the terminal point determined by negative is in the given quadrant. Okay? So let's say we want to figure out the sign of tangent times cosine of the same angle, and we know that it is in quadrant 2. Well, in quadrant 2, only sine is positive. So tangent is a negative number, cosine is a negative number, and so if we multiply two negatives, our answer is positive. So if we're multiplying these two values of our theta, then we get a positive answer. Okay? Sine squared of theta times cosine theta. By the way, if you see, instead of writing this, we normally write this. So if you see a 2 right there, it's where you're being asked to square your value. If it's a 3, you're cubing your value, and so on. That's just notation. Okay? So let's do sine squared times cosine, and our theta value is in quadrant 4. So in 4, cosine is positive. So Sine is negative, but I'm going to have a negative number squared times a positive number. If you square a negative, you're going to get a positive times a positive, so your answer overall is going to be a positive value. Okay? Now, tangent theta times sine theta divided by cotangent theta, and we are in quadrant 3. In quadrant 3, tangent is positive, so cotangent is also positive. So what I have here is going to be a positive value times a negative value over a positive value. Multiplying here, you're going to get a negative divided by a positive, so your overall answer is negative. Okay. Now, cosine theta times secant theta in any quadrant. Okay, so let's think about this. Well, cosine, we've got our chart, we can easily figure that out. But secant goes with cosine, right? Secant always has the same sign as cosine. So if I'm multiplying two cosine values together, well, just the signs of them, I'm either going to be multiplying a positive times a positive, because cosine and secant always have the same sign, or I'm multiplying a negative times a negative. Either way, you get a positive answer. Okay. Now let's look at a slightly different type of problem. We want to find the exact values of the trig functions of theta from the given information. We know that tangent of theta is equal to negative 3/4. We know that our theta value puts us into quadrant 4, and we're asked to find sine of that value. Okay, so what do we know? We know that tangent of theta is equal to y over x, no matter what our radius is. And so right now we have a value that we can just figure out. Now we can figure out whether our y value or our x value is supposed to be negative. One of them is. And if we are in quadrant 4, then cosine is positive, which means our x values are positive and our y values are negative. So this is negative 3 over positive 4, which means that we can use the terminal point for negative 3. We know that the ray associated with this angle passes through the point for negative 3. Now we have a problem like we were using earlier in the previous page. We want to find our r value first. R is the square root of x squared plus y squared. So this is the square root of 16 plus 9, which is the square root of 25, which is just 5. Now we have enough information to find our sine value. Sine of theta is y over r, so negative 3/5. Okay. Now let's do the same type of thing. We have cotangent of theta is equal to 3/2. And we're told that secant is positive. Okay, so let's think about this. Okay, cotangent of theta is x over y. So we can do this. Now, cotangent is a positive number in either in either quadrant 1 or quadrant 2. Okay, so we've got to figure out which one we're in. We are told that secant is positive. Well, secant goes with cosine. So we're actually being asked to we need to figure out which quadrant has both cotangent and cosine as positive numbers. Okay, so cosine is positive here and here. Cotangent is positive here and here. The only place that happens is in quadrant 1. Okay, so this tells us we are in quadrant 1, except I can't write 1. And that means our x value and our y value is positive. So we know that the ray associated with this angle passes through the point 3, 2. Now we need to find our r value. So we do the square root of 3 squared plus 4 squared, which is actually the same thing as what is up here. So we have the square root of 9 plus 16, which is the square root of 25, which is 5. Except I just made a big mistake here. And I don't want to start this video all over again, so please excuse my mistake. I plugged in a 4 here but it should have been a 2. R is equal to the square root of 3 squared, let's do this correctly, plus 2 squared. So I have the square root of 9 plus 4, which is the square root of 13. I apologize for that. This is your correct R value. Now to find sine of that theta, that is y over r. So 2 over the square root of 13, which we need to rationalize to get 2 times the square root of 13 over 13.